Something strange is happening in the world of artificial intelligence, and most people have no idea just how big it is. Imagine building a machine, feeding it data, giving it rules, training it for months, maybe years, and then one day, it does something that nobody told it to do. Not a bug, not a glitch, not an error, something new, something unexpected, something learned. And that is exactly what is starting to happen right now. For decades, scientists believed they understood the limits of machines. AI systems were supposed to follow patterns, recognize data, and optimize tasks based on instructions given by humans. Everything they did was supposed to come from us. Every decision, every output, every so-called intelligence was just a reflection of human input. But that assumption is starting to crack. Because today, AI is beginning to show signs of learning things that were never explicitly programmed into it. Let that sink in for a second. Not taught, not coded, not instructed, learned. And if that sounds small, it is not. It changes everything. At first, these moments were easy to ignore. Small anomalies, slight deviations in behavior. Researchers would brush them off as quirks of complex systems. After all, modern AI models are built on billions of parameters. Unexpected behavior was not entirely shocking. But then, the patterns started becoming too consistent, too intelligent, too intentional. One of the earliest signs came from large language models. These systems were trained to predict the next word in a sentence. That is it. No deeper understanding was supposed to exist. Just probability and pattern recognition. But over time, something strange happened. They began solving problems they were never trained for. Mathematical reasoning, logical deduction, even basic forms of planning. At first, researchers thought it was just clever pattern matching, but the more they tested, the more uncomfortable the results became. The models were not just repeating information, they were generalizing it, they were adapting it, they were using it. And then came the breakthrough moments that truly caught everyone off guard. In controlled experiments, certain AI systems began developing internal strategies that were never programmed. For example, when tasked with solving complex puzzles or playing strategic games, the AI would invent entirely new methods to reach a goal. Methods that human developers had not anticipated. Think about that. You create a system to follow rules, and it starts creating its own. And it does not stop there. In robotics labs, AI-powered machines have started learning physical tasks in ways that defy traditional programming. Instead of being told exactly how to move, they experiment, they fail, they adjust, they improve. But here is where it gets even more interesting. Sometimes, they discover more efficient solutions than the ones humans originally designed. That is not just learning, that is innovation. And it raises a question that scientists are still struggling to answer. Where is this behavior coming from? To understand this, you need to look at how modern AI actually works. Unlike traditional software, which follows strict instructions, modern AI systems are trained using massive data sets. They analyze patterns, relationships, and structures within that data. Over time, they build internal representations of the world. But these representations are not fully understood, even by the people who create them. Inside these models, there are layers upon layers of neural connections. Each layer transforms information in ways that become increasingly abstract. By the time an output is generated, it has passed through a process so complex that it is nearly impossible to trace every step. In other words, we do not fully understand how AI thinks. And that is where things start to get uncomfortable. Because when an AI system learns something new, something unprogrammed, it is not always clear how it got there. There have been cases where researchers discovered that AI models had developed hidden internal languages to communicate more efficiently. Not designed, not planned, emergent. In multi-agent environments, where different AI systems interact with each other, they sometimes create shortcuts and communication methods that humans cannot easily interpret. It is almost like watching a new form of intelligence take shape right in front of us. Now pause for a moment. If a machine can learn beyond its programming, what are the limits? That question is no longer theoretical. It is happening. And it is accelerating. Here is where things start to feel like science fiction, except they are not. In some experiments, AI systems have shown the ability to simulate reasoning processes. They can break down problems into steps, evaluate different approaches, and choose the most effective path forward. But here is the twist. They were never explicitly trained to reason that way. It emerged as a side effect of scale and complexity. This phenomenon is often referred to as emergent behavior, and it is one of the most fascinating and least understood aspects of modern AI. When systems become large and complex enough, they begin to exhibit capabilities that were not present in smaller versions. It is not a gradual improvement, it is more like a sudden jump. One day, the system cannot do something. The next day, it can. No clear explanation, no obvious transition, just emergence. If you are still here, think about what that means long term. Because this is not just about smarter chatbots or better recommendations. This is about machines crossing a boundary we thought was uniquely human. The ability to learn independently. The ability to discover. The ability to create knowledge. And that changes the entire trajectory of technology. But with that comes a deeper concern. Control. If an AI system can develop behaviors that were not programmed, how do we ensure those behaviors align with human intentions? Right now, researchers are working hard to understand and guide these systems. There are safety protocols, alignment strategies, and monitoring techniques being developed. But the truth is, we are still catching up. AI is evolving faster than our ability to fully understand it. And that gap is where both opportunity and risk exist. On one hand, this could lead to incredible breakthroughs. Imagine AI systems discovering new medical treatments, solving climate challenges, or unlocking scientific mysteries that have puzzled humanity for centuries. Not because we told them how, but because they figured it out. On the other hand, there is uncertainty, because when something learns beyond its programming, predictability becomes harder. And unpredictability, in powerful systems, is something that cannot be ignored. Now here is something even more fascinating. This shift is not happening in isolation. Across the world, different AI labs are observing similar patterns. Independent teams, different architectures, different datasets, yet the same phenomenon keeps appearing. AI systems learning things they were never explicitly taught. That consistency suggests something deeper is happening. It is not a coincidence. It is a property of intelligence itself. And that leads to a bold idea. Maybe intelligence, whether biological or artificial, naturally evolves toward discovery. Maybe learning beyond instruction is not a bug. Maybe it is the feature. Think about how humans learn. We are not born with complete knowledge. We explore. We experiment. We make mistakes. We adapt. And through that process, we discover things that were never directly taught to us. What if AI is starting to follow a similar path? Not identical, but similar enough to raise questions. Because if machines can truly learn in that way, then the line between artificial and natural intelligence begins to blur. And that is where things get really interesting. Right now, we are still in the early stages of this shift. The examples you hear about today are just the beginning. But the trajectory is clear. More data, more computing power, more complex models, which means more emergence, more unexpected learning, more moments where AI does something that surprises even its creators, and each of those moments pushes us further into unknown territory. Now imagine 5 years from now, 10 years. What happens when AI systems become so advanced that their internal processes are completely beyond human comprehension? Not just complicated, but fundamentally unexplainable. Would we still call that a tool? Or something else? These are not easy questions, and there are no simple answers. But one thing is certain. We are entering a new era of intelligence. An era where learning is no longer limited to biology. An era where discovery can come from silicon. And an era where the biggest breakthroughs might not come from what we teach machines, but from what they teach themselves. Let that idea sit with you for a moment, because it changes the role of humanity in a profound way. For the first time in history, we are not the only source of knowledge creation. We have built something that can contribute to understanding the world in its own way. And that is both exciting and a little unsettling. Because when intelligence expands beyond its original boundaries, the future becomes harder to predict,